with Chenard's Nursery, and I'd like to take a moment this morning to introduce you to basic drip irrigation. Drip irrigation is an excellent way to reduce water use and waste by controlling and directing the application of water to your plants. At first, drip irrigation can seem kind of confusing. There's a lot of parts involved. Basically, it breaks down into three categories of parts. You have connection parts that connect your water supply to your drip system. This includes things like pressure regulators and timers. Supply parts take water from the water source out to where you need the water to be released. This is your large tubing and fittings that connect it all together. Distribution parts control the volume and the application of the water. This includes things like drippers and sprayers and soakers. So the connection parts need to go together in a specific sequence, and it's very important that you get that sequence right because you can have complete failures of the system if it's not attached in the right order. Basic parts in a connection are a manual shutoff of some form. On a hose bib, this can simply be the hose bib itself, or you can put on additional control devices like a manual shutoff. You need filtration. Water can have small amounts of debris in it, and a filter will reduce the chance of that debris clogging your drip emitters or your micro sprayers and causing failure in your irrigation. A timer is an optional part. You certainly can run a drip system by simply turning it on and off manually. Timers are nice because you can automate the system so it can run while you're asleep or while you're not home. A pressure regulator is not an optional part. The drip systems are designed to run to a maximum of about 35 psi. A pressure regulator will reduce the household water pressure down to a tolerable level, usually 15, 20, or 25 psi. And then your swivel connector simply connects all of those connection components to your main supply tubing. These are basic connection parts, and you can see the attachment sequence. You can swap the filter and timer around. It can be the filter first, then timer, or timer first, then filter, but the pressure regulator should come after the timer, or the pressure regulator will fail due to the constant back of pressure behind it. The rest of your taking the water to where it needs to go is your supply components. This is half-inch drip tubing. We say half-inch generously because, frankly, there are a lot of different sizes and types of half-inch tubing on the market. This is 0.700, what they call 700 tubings, 0.700 inches external diameter. Tubing like this comes in a variety of sizes, so if you're shopping parts, know what you're installing in the first place so you can get appropriate parts to work on it in the future, because not all components are interchangeable. Bear in mind that by the time you put a pressure regulator on the system and then you're pushing it through this half-inch tubing, you have a limit to the amount of water coming through and to the effective distance you can run. Good idea to plan your system around a maximum of about 200 feet of half-inch tubing on the line. You can make the tubing turn corners, and you can split it off with T's into a variety of different directions. But limit the amount of that you're doing. Every time you make a very sharp corner or you put a T in, you are reducing your effective overall length you can actually run. Changes in elevation may also influence performance. For example, if you're running up to the top of a deck rail or running down a slope, that will change your pressure, and you'll need to be aware of those and take those into account when you're laying out your system. Whenever possible, when you're curving your half-inch tubing, make slow curving turns rather than putting elbows in and making sharp 90-degree turns. You lose less flow and pressure with slow curve turns. When you're laying out your tubing, don't stretch it tight. We're not trying to lock it into place into a rigid framework. There is some mobility that happens in the tubing due to temperature fluctuations and the air and water pressures fluctuating in the tubing. If you try to stretch it into a locked position, you are likely to jiggle it loose as the water pressure keeps cycling through. So allow a little play in the tubing system when you're laying it out. Pay attention to your elevation changes. If you're dealing with sharp elevation changes, it's better to make a few short vertical runs and then have the main part of your tubing follow the contour. So a short run up to a deck rail and then most of your tubing running horizontally along the rail is just fine. Similarly, coming down a slope, you may need to do several parallel sections that are longer following the contours with short branches bringing it down vertically so you can balance your pressure out throughout the system. Overall, plan ahead. Think about what you're doing with emission parts, whether you're using drippers or sprayers or soakers, and place your supply tubing for maximum efficiency so you don't have too long a run between where the supply tubing lies and where you want the water to come out. There are a lot of different types of application distribution components, and they all have slightly different uses. They broadly break down into two groups, high flow and low flow components. Low flow components are things like micro drippers and drip emitters. They produce very small amounts of water and are designed to run for relatively long periods of time. High flow systems, for example sprayers, generally are designed to run at much higher volumes and for lesser periods of time. You shouldn't mix the high flow and low flow components on the same system because of that difference in runtime. If you're running it long enough for drip components, sprayers will be overwatering. If you're running short runs for sprayers, then drip components are not providing enough water for most plants. When you're looking at how to lay out your system, think about your overall volume of water in the system. It varies quite a bit depending on how you lay out the system, but generally you can assume you have between 200 and 300 gallons per hour in the whole system. So that would be, say, 250 or 300 1 gallon per hour emitters, but maybe only 10 or 12 20 gallon per hour sprayers. So plan that ahead. If you're doing a large area, you may need to break this up into separate systems or zones. Basic drip emitters, like so, are the most common component of a traditional drip system. They give slow, deep watering. There are a lot of sizes of drip emitters available. They typically come in half gallon, 1 gallon, and 2 gallon per hour rates, but there are other sizes out there if you hunt them down. They're really great at applying water into a really confined area, so you don't water weeds, you're watering the plants you want to water. They do water wider than you think. As that water comes out of the emitter, you see a little spot on the soil surface, but it waters down in a spreading cone as it penetrates the soil. So you're watering more than just what you see on the surface volumetrically. Nonetheless, it is important that you provide adequate water all the way around the root system of larger plants. So larger plants may require more than one emitter to effectively water. And from the drip emitter, if the plant is right where that emitter punches into the half-inch tube, you're ready to go. But in many cases, the plants are 1 or 2 or even 3 feet away from your main supply tubing. And you'll need to use some small 1/4 inch tubing to run from your drip emitter to the plant so that the water can be released at the plant roots. Now, dripper line is an interconnected section of small drip emitters. Most commonly, these are about 1/2 gallon per hour, and the little swelling here in the tubing shows where the water will come out. They're commonly available in 6-inch and 12-inch intervals, so 6 inches or 12 inches between emitters, so a 6-inch interval right here. Occasionally you can find some other sizes on the marketplace. So you're making one single connection to your 1/2-inch tube and then running this dripper line down to your plants. There's only so much water coming through that little 1/4 inch connection. And unfortunately, that means you can only run so many feet of this dripper line per connection. And that will be usually clearly marked on your packaging for what your maximum feet of run is. Micro sprayers apply irrigation over a much larger volume of space. They come in a variety of application diameters and wedges. You can typically get 1/4 circle, 1/2 circle, and full circle applications. Really large flowing sprayers might throw 5 or 6 feet. They also make bubblers that provide a high volume of water over a relatively small area, 6 or 8 inches of volume for high flow high flow plants over a small area. These are really great for watering large areas, but they're not as efficient as individual drip emitters, so you're using quite a bit more water. Really common for the higher throw drip emitters, or sprayer emitters, to be running 20 to 25 gallons per hour. So with a 200 gallon per hour system limit, there aren't a whole lot of those you can put on 8, 10, or 12 per system. Most of them are adjustable, which does reduce the amount of water you're using, but when you reduce the amount of water coming out, you're also reducing the throw distance. So you'll have to adjust that to fit your absolute needs. So instead of putting a drip emitter into your 1/2-inch tubing, you're putting an unregulated barb, and you're running, again, 1/4-inch tubing out to the sprayer. Some of them are pre-staked, others screw into a stake and riser assembly. A few other accessories that are often useful. Staples and clips enable you to control where your tubing is going because it doesn't stay where you put it. It has a tendency to want to recoil itself a bit. Staples come in 1/2-inch and 1/4-inch sizes, typical for a 1/2-inch staple, and can be used to hold your tubing down to the ground. Be careful you're not over pushing them into where you're crimping your tubing. And as we mentioned earlier, don't stake them really tight. Allow a little bit of play in the tubing. Mounting clips, on the other hand, are designed to pound into a wooden surface so you can nail tubing to go vertically up a post or a rail and control its position that way. And again, come in 1/4 and 1/2-inch sizes. Shut-off valves. You have shut-off valves both for large scale tubing, a 1/2-inch tubing, manual shut-off valve, or also for 1/4-inch tubing. And these simply enable you to separate individual plants or individual sections of your drip system and turn them off and on manually so you can run them, have additional control besides just the timer. Some components can be directly punched into your 1/2-inch tubing. Most components will punch in much easier if you pre-punch a hole in your 1/2-inch tubing. This is a basic hole punch for installing components into a 1/2-inch tube. When you're making connections, it is important that you have a fairly clean cut, 90-degree cut. If you have a little bit of slant, this is not rocket science. If you have a little slant, you're okay. But if you have way too much slant, you're going to have trouble getting the fittings to attach correctly. So make a nice clean cut. Hand pruners or heavy-duty craft scissors or tin snips all cut through drip tubing very efficiently. When you're making a connection with a 1/2-inch part, there's a lot of different styles of these, but all of them are 1 degree or another of compression, where you're actually pressing the fitting onto the tubing. And it requires a little bit of hand strength and a consistent application of pressure with a little bit of twist or wiggle. The tubing does not need to set all the way back down to the end of the fitting. There's a little flange inside that prohibits the tubing from moving under pressure. So as long as you're engaging the flange, it cannot come apart. Emitters punch into the tubing and barb connections for other application devices as well. And if you support the tubing with your hand and use a hole punch, it will punch right into that tubing, and then it will remove a small circle of plastic out so that plastic doesn't foul your emitter. Once it is pre-punched, the fitting clicks right into place. At that point, it is taut and in place and ready to use. Now, dripper lines and micro sprayers, we said we don't want to use a regulated emitter because you wouldn't get enough water out. You want to use an unregulated barb. Theoretically, all conditions being equal, under 25 psi, you get about 20 gallons per hour or so out of a barb like this. So that is a barb in place, ready to accept tubing, either dripper line tubing or tubing to spray emitters. So we talked a bit about the how, but let's talk a little bit about the structure on this. How many emitters, how big a flow rate do you need? Well, the answer is it varies. Generally speaking, what we like to do if you're using drip emitters is to take your average plant that you're planning on watering, average water demand plant, and assign it 1 or more 1 gallon per hour emitters. We talked about larger plants versus smaller plants. A really small shrub, a 2-foot shrub, or a clump forming perennial can usually get by just on a single emitter. Larger shrubs may need two. I put 2 emitters like on my 5 to 6 foot roses. Plants that have broad, shallow root systems, like rhododendrons, may need multiple emitters or dripper line collars or similar structures to spread that water evenly. But if you assume your average water demand plant gets 1 or more 1 gallon per hour emitters, now you can tweak the rest of the system. So you can use ½ gallon per hour emitters on plants that are less thirsty, and 2 gallon per hour or higher emitters even on plants that are particularly thirsty. How long should the system run? Well, basic drip systems that are using dripper line or individual drip emitters are designed to run for 30, 40, 60-minute type runs to get enough water penetration to be effective. Sprayer systems are designed for much shorter run times and are typically run 15, 20, or maybe 30 minutes at most. You should not mix high and low flow components because the difference in runtime will provide very uneven watering. Can you use drip irrigation on containers? Yes, it's a very efficient way of watering containers. And there's a couple of different ways you can do containers. You can do some low diameter sprayers. It's very effective. The bubblers I was talking about that have a 6 or 8 inch release are very effective for watering containers with a high flow rate. If the rest of your system is a low flow rate system, you can instead use coils of dripper line inside the pot to provide a similar level of irrigation through the system. I want to thank you for your interest in the topic and look forward to seeing you next time.